So hello, welcome to my channel, and I'm going to discuss the topic of asymptotes and the tracing of the curves. Asymptotes I have discussed previously. So asymptote is a line to which the curve is going to meet at infinity, not going to meet at all physically. Infinity means never going to meet it. So we will discuss how to find the asymptote. We have done this previously, and I told you how to find the asymptotes, and we can find the asymptotes parallel to x and parallel to y axis also, and the asymptotes which are parallel to each other and the asymptotes which are not parallel to each other at all. So let us discuss how to trace a given curve. So the equation given to us is ay square equal to x into a square minus x square. So the first point is symmetry. So you can see here the power of x here is 1 and here it is 3. So x is odd, power of x are odd, only y is having even power. So this is symmetrical about x-axis, the first point. So we will draw this along with our discussion. Symmetrical about x-axis, same on this side and this side. Now the second thing is whether it passes through origin or not. There is no constant term, means which does not involve x or y. So yes, passes through origin. It passes through the origin. Then third is the tangent to the origin. How to find the tangent to the origin? Put the lowest degree term equal to 0 in the equation. And what is the lowest degree term here is x equal to 0. So x equal to 0, that is y axis, is tangent to the curve at origin. This is the tangent to the curve at origin. It means that the curve which is symmetrical about x-axis and touching the y-axis, so it should be somewhat like this here. This is the next point, and after this find the points where the curve meets the axis. So when x equal to 0, y is 0, so one point is origin. Second is when I put y equal to 0, x is 0 and x is plus minus a. So 0, 0, 0, a0 and minus a0 meeting at 3 points. Suppose here we have a0 and here it is minus a0. Now we have to find the tangent at these points. For this, shift the origin. For this point, shift x equal to x plus a and y to y plus 0, a0. So the equation becomes ay square equal to x plus a square minus x plus a whole square. Put x equal to x plus a, and if you solve this equation, you will find the equation of tangent and then put the lowest degree term equal to 0. So x plus a into a square minus x square minus a square, so minus x square minus 2ax, a into y square. So from this you can find the equation of tangent at the point x equal to a into 0. So what is the lowest degree term in the equation? This gives you x equal to 0. So see, lowest degree term is x. So x equal to 0, that means y-axis. Tangent is parallel to y-axis at this point. So this line will be a tangent. So shape of this curve here will also be like this. Now find the tangent at minus a0, and for this shift x to x minus a and y to y plus 0. So the equation becomes a y square equal to x minus a square minus x minus a whole square, and equate to 0 the lowest degree term in this equation. Here you will find that here also the lowest degree term is x equal to 0. So the tangent is parallel to y axis, lowest degree term of this equation. So this is the tangent parallel to y axis, x equal to minus a. Now see whether the curve is existing between these points or not. So for finding the existence of the curve, what is the condition? X should be positive, otherwise y will be not real. X should be positive, greater than equal to 0, and a y square equal to x, let me write here, a minus x, a plus x, or I can write it like this, minus of x minus a, x plus a. So one is x should be positive, x minus a plus a. So if x is greater than a, if x is greater than a, this term is positive, this is positive, this is positive, so y will be negative, so it is negative. That means y will not be real because this is y square, so x should not be greater than a, it cannot go beyond this side. If it is less than minus a on this side, then this minus x will be positive, and this is less than minus a, suppose minus 2a, this is negative, and a minus 2a negative. So plus minus minus plus, overall will be plus, so here it is positive. So it is existing on this side. If it is between minus a to a, suppose minus a by 2, then this term is negative, this term is positive, negative, positive, and this minus x is positive, so overall negative. So it is not existing between minus a, let us find between not minus a to a, we have to take 0 also here. This is origin 0. X equal to 0 is also a point, minus a plus a. So if it is between 0 to a first, suppose you take a by 2, then this is x is positive and x minus a is negative, plus minus plus, so overall minus, so minus minus plus, so it is positive, means curve is existing here. Then minus a to 0, between minus a to 0 if you put any value, you will find that this term is negative, so y cannot be negative, so it is not existing between this, existing between this, not existing on this side, existing on this side. So there is curve is not existing here on this side, and this line is tangent to the curve at this point, so shape of curve here will be like this. The exact shape you can draw by writing different values of x and finding different values of y. Now for this part, now in this region curve is not existing. For this part between 0 0 to a 0, how do we find the point of inflection? Differentiating, we get 2a y dy by dx equal to a square minus 3x square. So dy by dx equal to 0. Why I put dy by dx equal to 0? Because shape will be like this. So the tangent here will be parallel to x axis. So for that dy by dx is 0. So this gives us x equal to plus minus a by root 3. So it cannot be minus a by root 3. So we have to take plus a by root 3, because in this region curve is not existing. So a by root 3 means a upon 1.73, around 0.6a, and for this you will find that for this value of x, second derivative will be negative. For this value of x. Now find y for this value of x. So y maximum, y for x equal to a by root 3. Put in this equation and find the value. So this is equal to a by root 3 a square minus a square by 3 to a square by 3 ay. So y is into 1 by a. So y is equal to plus minus under root of 2 by 3 root 3 a. So this is how you can find the value, and that will be the point of inflection, and for different values of x put in the equation and find the values of y. Here at this point y is maximum for this value of x. So friends, this is how you can draw the tangent, draw this curve. It is very easy, seems to be difficult, but this is very easy to draw. So now I ask you a question. You have to find the area enclosed by the curve between this point to this point. How will you do? If you know the shape of the curve, if you can draw this, if you have enough practice, then you can find the area very easily. Take a strip like this, and area is integral of y dx, and x is varying from 0 to a, and same on both sides, so double of this. This is easy. You can also find the volume of the paraboloid, that we will be discussing, but I will give you an idea of that. Suppose this curve is rotated about x-axis, axis of symmetry, then what we will get, this will be a curve, this will be a solid rotated about this. So this strip is also rotated, so we will get a circle like this. So its volume will be integral pi y square dx, and x is varying from 0 to a, and it will not be double. Similarly, you can find the length of the arc. Similarly, you can find the position of center of mass of this curve. This curve is existing on this side also. So it is very easy if you know the basic how to draw. So this is all for today. Thank you very much.